All right, so let's begin. The questions are from the Topical, Cambridge Topical book. We're looking at chapter on circular motion. Questions 36 and 37. Question 36 is, again, what's the word that we want to use to describe the math associated with this Tuesday class, people? Anybody? What's the word I told you this was, this question was dealing with? You can type the answer in the chat window. Marcus? Ajay? Nobody? Can you remember the word conical pendulum? Yeah? So we're dealing with a conical pendulum. All right? So this is the first question here. And it deals with a conical pendulum. What we mean is that there is a force. This force here, force P, is also called the lift force. The lift force is a force that is perpendicular to the wings of the aircraft. And it is what provides an aircraft, allows an aircraft, not to fall to the ground. Let me just write that. The lift force is perpendicular. The lift force is perpendicular to the wings of the aircraft. All right? This is what allows an aircraft to have horizontal flight. Right? It's called the lift force. And that is it right there. Now, in order for this aircraft to move in a circle, we know that once a body is moving in a circle, there must be a net force acting on the body towards the center of the circle. And from our session on Tuesday, we said that this, what we call the centripetal force, is provided for by the horizontal component of this lift force. At the same time, that lift force also has a vertical component. The lift force also has a vertical component. And what is the vertical component of the lift force going to provide for? Anybody? Very well done, yes, the weight. The vertical component of the lift force, not force, is equal to the weight of the aircraft. All right, so in this situation here, I'll show you what I'm talking about. I'll put an arrow. I'm hoping this arrow works. We have an arrow going up. That is the vertical component of the lift force. That vertical component of the lift force will be exactly equal to the weight. So that's how the aircraft can maintain horizontal flight. It doesn't either gain or lose altitude. And again, that force P also has a component. Let's change the color. That force P also has a horizontal component. The horizontal component acts towards the center of the circle. So you see, from what we have here, we can consider the two components of P as having a horizontal component that provides the centripetal and the vertical component that is equal to the weight. And from what we've done about components, we can take and break up that force into components. You can take any force and break up that force into its components. So could you tell me, if you look at the triangle here, well, I mean, I'm not showing a triangle, I'm showing the two components. I can draw the triangle I can draw the triangle right here for you, right? And that's a right angle triangle. This is the centripetal force, and this is the lift force. So I'm sure you all can tell me the horizontal component is going to be what? P sine or cos 35. P sine or cos 35. Just type the answer in the message, in the chat window. P sine 35. Yes, everybody seems to be on the ball. So we have P sine 35. I'll just write it. I'll type it, I suppose, in blue. P sine 35 is given as our horizontal component. And at the same time, the vertical component, yes, I do have to actually say that because we know this, the vertical component P is going to be P cos 35. So far, so good. So again, right now we're just simply deconstructing the question. The question tells us that the weight of the aircraft is 392 by 10 to the 5, 3.92, sorry, by 10 to the 5 Newton. So if that is what the force is down, there's going to be an exact equal opposite force. So we know immediately that P cos 35. P cos 35 must be equal to 3.92 by 10 to the 5. And again, that's just reading the question. The aircraft is moving with a mass of 4 by 10 to the 4 and a speed of 250 meters per second. That's the information we have. So let's get into what they're asking us for. State the vertical component of P for horizontal flight. So the vertical component of P is P cos 35. But beyond that, we can know its value. Its value up pointing up must be 3.92 by 10 to the 5. Right? 3.92 by 10 to the 5 is the vertical component of P pointing up. That's part one. And then they're asking us to calculate P. So we simply equate P cos 35 to 3.92 by 10 to the 5. You just equate them. All right? And solve for P. So P would therefore be, from this part of the question, P, I'll try to write again. P would be, P would be equal to, writing is going to be horrible, people. I'm doing it with a cursor, so let's excuse the writing. It's going to be 3.92 by 10 to the 5. That's a 9, right? Oh, goodness gracious, no way. I'll write that. I'll just have to type it, I suppose. Let's do it. It's going to be 3.92 by 10 to the 5. Since I can't put exponents here, I will have to do the exponents with this little 2 here by 10 to the 5. Oh, that's a blue 5 too. Lovely. Kaleidoscope. Over the cos of 35. Over the cos of 35. And that's pretty much it. You just run the calculation, you get to it. Calculate the horizontal component of P. Now, from this, we're getting P, right? Once we get P, the horizontal component of P would be this value multiplied by the sine of 35. So that's a no-brainer. The answer to this part, the value of P is 4.79 by 10 to the 5. Again, that is 4.79 by 10 to the 5. That's P. See if I have a better luck with this. 4.79. I left out the point. By, of course, 10 to the 5. The horizontal component of P now. What's the horizontal component of P? That value is 2.74 by 10 to the 5 when you run the calculation. 2.74 by 10 to the 5. Then they're asking us for use Newton's second law to determine the acceleration of the aircraft. Now, we know that the acceleration is called the centripetal acceleration. And we know centripetal acceleration is equal to two things, v squared over r, or the centripetal acceleration is equal to omega squared r, omega being the angular velocity. In this question, we were not given omega, or we were not given a means by which we can find omega, but certainly here's our v, all right? But we don't know r either, so we're in a bottleneck there. We're in a bottleneck there, all right? How then do we work ourselves out of this? We know we have just found the centripetal force. T sine 35 is in fact the centripetal force. That is equal to 2.74 by 10 to the 5. Oh, rubbish. I'm just trying to show you all how when they ask for something, the things that come to our mind like this and this may not allow us to get the answer to the question. That's why I'm creating that that argument. I'm showing you the word acceleration or centripetal acceleration evokes these two equations. And I'm showing you that although you can pull these equations up and you find you don't have r, you'd have to go back to the drawing board and find another thing that will allow us to get the centripetal. And this is the way FC is equal to ME, M by EC. FC is equal to M by AC. So it's just a matter of, is this 10 to the 5? I think it's 10 to the 5. 2.74 by 10 to the 5, not by 10 to the 4. 10 to the 5. Just talking too much. FC is equal to MEC. So you just divide this by the mass, and they've given the mass to be 4 by 10 to the 4. So again, that's pretty straightforward. The answer for the centripetal acceleration is 6.86 meter per second squared. 6.86. And the last part, calculate the radius. So again, once we found the acceleration at 6.86, we can simply use this form of the equation. We can simply use this part here, v squared over r part. See? We can simply use the v squared over r. We got v right there. So it's r would be equal to 250 squared over 6.86. That gives us a value of 9.11. 9.11 kilometer. 0.11 kilometer. Right? So that's it. Question covered. It took us 18 minutes. And let's just get to the other one. I'm going to clear all drawings now. If you want to take a screenshot, you can take your screenshot in 5, 4, 3, 2, 1. I'm clearing all drawings. The next question is a gravitation question that we scheduled to do tonight. Not gravitation, sorry, another circular motion question. We're not looking at gravitation until next week. Next week, Tuesday, we look at gravitation. Use Newton's laws and laws of motion to explain why a body moving with uniform speed in a circle must experience a force towards the center of the circle. And how are we going to come to that? Newton's laws of motion. Well, the first thing we know is that certainly the velocity of the object is changing. And once the velocity of the object is changing, the body must be accelerating. And when we did the thing on Tuesday, we showed that the change in velocity is towards the center of the circle. And therefore, the acceleration must have the same direction as the change in velocity. So we have this question: an aircraft of mass this is traveling at a constant speed of that in a horizontal circle of that. What is the angular velocity of the aircraft? Well, there's another identity we did on Tuesday where we said that V is equal to R omega. Let's change this color. V is equal to R, I'm going to use W for omega, but it's not really so. V is equal to R omega. And we have to find omega, so omega will simply be V over R. We have V, that is 0.2 kilometers, so that's 200 meters per second, divided by 1.5 kilometers. Well, I guess we can just work in kilometers. It's 0.2 over 1.5. All right, and the answer would be 0.13 radian per second. Do that again. So omega would be equal to V over R. V over R, and that will be equal to 0.2 over 1.5, sorry. All right, and I'm assuming, let's pull up a calculator here. 0.2, got to use this, 0.2 divided by 1.5 equals, right? So we get the answer of 0.13. Show on a sketch the forces acting on an aircraft in a vertical plane containing the aircraft and the center of the circle. All right, so we just did that, right? The last question, where we did the components of the vectors. Find the magnitude and direction of the resultant. The magnitude and direction of the resultant would be the centripetal force. It's a graph. It's showing forces. So I mean, very quickly, I can show that. We can have the weight acting down. That's a weight there, and then we can have the horizontal component of the lift force as we had before. And then we have the vertical component of the lift force that is exactly equal and opposite to the weight. So these are the three forces acting. And these two are really components of the lift force. So instead of actually putting these two, we should really have our lift force. The lift force is going to be at an angle like this. And if we want to look at find the magnitude and direction of the resultant, what the question is really asking is it's asking for, let me copy here. We can't copy these things apparently. But what fun. All right. The result, they supposed to be like this, right? May have be out a little bit, but yeah. These are the two forces that we are combining. Sort of. You have to be, I'm doing it freehand, so I guess we would never get it perfectly. But the resultant of these two forces is simply this force. That's what they want us to show. They want us to show, sketch the forces acting on the aircraft. And what are the two forces? The lift force and the weight, containing the aircraft in the center of the circle. The center of the circle will be somewhere here. And find the magnitude and direction of the resultant. The magnitude, the direction is towards the center of the circle, of course. The magnitude would be what? M R omega squared, or mv squared over r, anyhow you want to call it. Next, the resultant R is equal to mv squared over r. mv squared over r. Okay, now we have m, we have v, and we have r. So that is the magnitude of the resultant. Explain why the force is exerted. Explain why a force is exerted on the passenger by the aircraft. In what direction it is force? Well, we did mention on Tuesday that when an aircraft is turning a corner, the aircraft will, I'll just draw a rectangle for the aircraft if you don't mind. Well, I don't know if I could draw a rectangle that is skewed. Apparently not. Select. No. Undo. I will just draw a big blotchy line as the aircraft. So this is our aircraft. Remember, the wings of the aircraft is perpendicular to the lift force, as I said before, right? So our aircraft would take on a position like this. That's our aircraft. So a passenger, this is a seat. The seat in the aircraft will take on the same, leaning. And the passenger, which we will represent as a pink blob, that's the passenger in the seat. The aircraft will be exerting a force on the passenger through the seat, like this. This is the force. This is the seat of the plane. The backrest will be, somewhere at the back there. So the backrest is somewhere there. Oops, sorry. Undo. The backrest will be there. The passenger is sitting on the seat. This is the base of the plane. The base of the plane is down here. So the seat is exerting a reaction force on the passenger in this direction. And that reaction force that the seat exerts on the passenger is what provides the passenger with his centripetal force. Meaning that that force will have a horizontal component equal to the centripetal force, and that reaction force will have a vertical component.
Do you want me to pay attention in class or not?
Right? So that's the force on the passenger. This is the seat of the passenger. This is the reaction force that the seat is exerting on the passenger. The horizontal component of that reaction force on the passenger is the centripetal force, because the center of the circle is down here. The center of the circle is somewhere here, right? And this is going to be equal to the weight. The weight of the passenger will in fact be acting down. Change color. Something different. The weight will be acting down, like so. So again, it looks just like the forces on the aircraft. On all of these, the subset of all of what we're dealing with is the conical pendulum. All of them have the same arrangement, where you have to take the oblique force and break up the oblique force, this force, into a vertical and a horizontal component. These cancel, and the resultant would be this, that is pointing towards the center of the circle, providing the centripetal force. So the last part says, explain why force is exerted on the passenger. Well, I didn't answer that part. It's obvious. If the passenger is in a plane and the plane is moving in a circle, the passenger is moving in a circle as well. So the passenger needs to have a net force on him or her because she or he is moving in a circle. So explain why a force is exerted on the passenger, and then by the aircraft, and then what direction is this force, and that is the direction of the force that the seat exerts on the passenger. All right, which is broken up into two components. Okay, I think we have about 3 minutes. Any other question? You'll follow this this discussion. We clear on the solution to these two questions. This class was limited to just answering those two questions that were given. Any clarifications needed from anyone? All right, it seems to be understood. All right, so again, we'll have these classes, we'll try to have these classes a couple times a week. Just half an hour, it wouldn't take long. We'll just identify what range of questions we're looking at, so people will have an opportunity to spend a couple hours or half an hour, whatever, on these questions. So when the discussion starts, you can ask any questions and seek clarification. So you wouldn't have to leave everything for the once a week session. Once there's a burning issue, even if you have a lab, people, even if you have a lab, what I'm going to try to do now, instead of having to try to type up solutions, if I don't have a solution to a lab, I will just have a Zoom session with one person. We can have a conversation. All right. We wouldn't necessarily tape that one, but let me end the taping, by the way. So it's now 9:29. I guess I'll bid you a good night now.